Today we are doing acid-base reaction, and I have taken few example of acid-base reaction. But before the acid-base reaction, we must be able to recognize an acid and a base. Then only we can write the acid-base reaction. Now I want to tell you something about acid and base. Look at this. How to recognize an acid. If it is written in words, then you can easily recognize, because something acid. Acid is written everywhere. Hydrochloric acid, sulfuric acid, nitric acid, carbonic acid, acetic acid, phosphoric acid, etc. But sometimes what happens, it is not given in words. Sometimes formula may be given. That's why you have to remember this formula. Hydrochloric acid means what? HCl. And sulfuric acid means what? H2SO4. And in the same way, nitric acid is HNO3. Before starting this chemical reaction, I told you all this formula. Carbonic acid is H2CO3. In the same way, acetic acid CH3COOH. In the same way, phosphoric acid H3PO4. These are the acids which frequently comes. Among these, actually, this hydrochloric acid, sulfuric acid, and nitric acid, they are very important. They frequently comes in the reaction. Now, you can recognize an acid in the chemical reaction very easily, whether it is given in words or it is given in molecular formula. But what is base? Now let's talk about base. We'll study about acid, base, and salt in another chapter, but before that, the reaction came. That's why we are talking about acid and base. Metallic oxide. Metallic oxide are bases. Metallic oxide means, just for example, sodium oxide, potassium oxide, calcium oxide, or maybe magnesium oxide, or maybe aluminium oxide. Any metal, if metal is found to be combined with oxygen, they form metallic oxide. And if this metallic oxide comes in word or in this formula, you have to understand that this is a base. Yeah, maybe many, but I gave you few. In the same way, metallic hydroxide. Metallic hydroxide are also base. Metallic hydroxide means the same thing if combined with, I mean to say, same metal. Sodium if combined with hydroxide, metal combined with hydroxide. Here metal combined with oxide. In the same way, potassium hydroxide. In the same way, calcium hydroxide. Or maybe magnesium hydroxide. Or it may be zinc hydroxide. Or it may be aluminium hydroxide. Metallic hydroxide are bases. Metallic oxide, metallic hydroxide. And there is an exception. You have to remember this exception, that is ammonium hydroxide. Ammonium is a radical, electropositive radical, ammonium hydroxide. This is a base, ammonium NH4, hydroxide OS. Two radicals are combined with each other, and this ammonium hydroxide is base. That's why before starting this acid-base reaction, we have to recognize the given compound is acid or base. Then only we'll be able to write this chemical equation, I mean to say balanced chemical equation of acid-base reaction. In the same way, you have to understand one more matter. First, when an acid reacts with a base, then they always form salt and water. And the definition comes from this. I mean to say, what is acid-base reaction? When an acid reacts with base, then they form neutral compounds salt and water. And this reaction is called acid-base reaction. This is the definition of acid-base reaction. But sometimes acid-base reaction is also called neutralization reaction. Why? Because when an acid reacts with base, then acid destroys the property of base and base destroys the property of acid, and they form neutral compound salt and water. So the reaction is also called neutralization reaction. Now let's start with these equations. Look at this, ammonium hydroxide plus sulfuric acid. You have to recognize this. Ammonium hydroxide is base. Just now I told you. Ammonium hydroxide, NH4OS. This is a base. Valency 1, 1, equal valency, no exchange. Sulfuric acid, we know directly S2SO4. And as we know, just now I told you, when an acid reacts with base, then they form salt and water. How salt forms? Hydrogen of acid is displaced by the metallic part of base. Means NH4 displaces hydrogen. It means NS4, and it takes the place of hydrogen. Sulfate is there, SO4. Now ammonium, valency 1, sulfate 2. That's why we have to transfer 2 of sulfate here. Ammonium 1 should not be transferred because SO4 itself is 1. And this is a salt. And another result is what? Water. Because we know that when an acid reacts with base, then they always form what? Salt and water. How salt forms? Metallic part of base displaces the hydrogen of acid and salt forms. Now we have to write their name also. This ammonium sulfate. Ammonium sulfate plus water. This way we can solve this. We can write this acid-base reaction, but it's not balanced. It is oxygen 1. Here it is 1. It's equal hydrogen 2. Hydrogen 2. Don't think about this hydrogen because here we have ammonium, here we have ammonium. That's why we'll count ammonium. This hydrogen here is different. S2, 2 hydrogen, 2 plus 1, 3 hydrogen. Here it is odd number. That's why I want to take here 2. Then in left hand side, 2 plus 2 becomes 4. And in right hand side also, if we take here 2, 2 2 is 4. Now oxygen, again we have to think about oxygen, whether it is balanced or not. Oxygen 2, balance. Now it's turn of sulfate. Sulfate 1, sulfate 1. Ammonium 2, ammonium 2. Now this is balanced chemical equation. Now let's talk about another reaction. Look at this. Hydrochloric acid when reacts with what? Sodium hydroxide. Then what happens? First, better to write molecular formula. Hydrochloric acid we know HCl. And sodium hydroxide we know Na for sodium hydroxide OS. Valency of sodium is 1, hydroxide is 1, no equal valency, no exchange. Now what happens when an acid reacts with base? Then metallic part of the base displaces the hydrogen of acid. That's why Na displaces hydrogen. NaCl forms. NaCl forms. Sodium valency 1, chlorine 1, equal valency, no exchange. And another product is what? Water. This is salt and water. Now we have to write its name. Sodium chloride. Sodium chloride, and this is water. Look at this, is completed, but whether it is balanced or not, we have to check it. Oxygen 1, okay. Hydrogen 2, hydrogen 1 and 1, 2 is okay. Chlorine 1, okay. Sodium 1, okay. Now this is also balanced. Now let's talk about third one, slacked lime. If you remember, I told you that calcium hydroxide is slacked lime. CaOS2. We have to remember this directly. I told you in previous class also. Plus nitric acid, SNO3. We have to remember this also. Now how do you understand this is acid-base reaction? This is metallic hydroxide. metallic hydroxide is base, and this is an acid, written directly acid. Okay, now what they form? Salt and water. How salt forms? Metallic part of this slack line displaces hydrogen, it means CaNO3. Calcium valency 2, nitrate 1 we don't have to transfer. Calcium valency 2 should be transferred. If we give valency to radical, then we have to put that radical in bracket. Okay, now next is very simple. Second product is what? Water. First is salt, second is water. What is the name of this compound? Calcium nitrate. Calcium nitrate. And another one is what? Water. Now we have to balance this equation. Oxygen 1, we are not counting this oxygen because nitrate and nitrate, both side nitrates are present. Oxygen 1, oxygen here 2. That's why if we take here 2, then oxygen is balanced. Now hydrogen 2 2s are 4, here 1, here 2. It means if we take here 2, then 2 plus 2, 4, balanced. Now it's turn of nitrate, nitrate 2, nitrate 2, calcium 1, calcium 1. This is balanced chemical reaction. Now next, let's talk about calcium oxide and hydrochloric acid. Calcium oxide, calcium Ca, oxide means O, hydrochloric acid, directly we remember HCl, and this is acid base reaction. How do we recognize? Metallic oxide is base and hydrochloric acid directly written acid. When acid reacts with base, salt forms. How salt forms? Calcium displaces hydrogen. That's why CaCl. Calcium valency 2, chlorine valency 1. 1 we don't have to transfer, CaCl2. Now another product is very simple. We have to write water. Acid base reaction produces water. Now what is the name of this compound? Calcium chloride. Calcium chloride plus water. Now this equation is balanced or not? Let's check it. Oxygen 1, oxygen 1, hydrogen 2, here only 1, that's why 2. Okay, hydrogen balance. Chlorine 2, chlorine 2, calcium 1, calcium 1. Okay, this is balanced chemical equation. Now look at this another one, caustic potash. We have to remember that caustic potash means potassium hydroxide, KOS, directly valency 1 1, equal valency, no exchange. Now carbonic acid, as I told you just before this reaction, S2CO3. Now this is acid, this is metallic hydroxide base. That's why acid base reaction, and potassium takes the place of hydrogen, KCO3. Potassium valency 1, carbonate valency 2. That's why K2CO3. And another product is what? Water. Now what is the name of this compound? Potassium carbonate. Potassium carbonate plus another one is water. Now we have to balance this equation. Oxygen 1, I am not counting this oxygen because carbonate we will count in, which is present in both sides. Oxygen 1, oxygen 1, okay. Hydrogen 2, hydrogen 2, okay. Carbonate 1, carbonate 1. Potassium 2, not equal, here we have to take 2. Now if potassium is 2, then hydrogen here 2, we have to count from the beginning. Oxygen 1, oxygen, here it is 2. That's why we have to take here 2. 2 oxygen balance, 2 2s are 4. Hydrogen 2, 2 4. Carbonate 1, carbonate 1, potassium 2, potassium 2. This way it is balanced. Now let's talk about ferric oxide. This is ferric oxide means what? Ferric, iron, ferrous, ferric, both are iron, but ic means more valency 3, os means less valency 2. Ferric oxide, iron valency 3, oxygen valency 2. That's why 2 should be transferred to iron, iron 3 should be transferred to oxygen, plus hydrochloric acid, HCl. Now this is metallic oxide base. Base is reacting with this acid. Now how do they react? Iron takes the place of hydrogen, FeCl. Now here it is ferric, that's why we are here also we are taking ferric chloride. That's why iron 3, chlorine 1 we don't have to transfer, FeCl3, plus next is what? Water. Now we have to write the name of this compound, ferric chloride. F-E-R-R-I-C, ferric, C-S-L-O-R-I-D-E, chloride, plus what? Water. Now we have to balance also oxygen 1, oxygen 3. That's why if I take here 3, oxygen is balanced. Now 3 2s are 6 hydrogen. If I take here 6, then hydrogen is balanced. Chlorine here, it is 3. Here chlorine is 6. That's why if we take here 2, 3 2s are 6. Okay, iron 2, iron 2. This is balanced chemical equation. Now next, let's talk about last one, zinc hydroxide. Let's talk about zinc hydroxide. Z and zinc hydroxide means OS. Zinc valency 2, hydroxide valency 1. That's why valency of zinc should be given to hydroxide. Hydroxide is radical. That's why I have to take it in bracket and then transfer the valency. This sulfuric acid means S2SO4. Now what is this? Metallic hydroxide base, and this is acid base reaction. That's why salt and water forms. Now how salt forms? Zinc displaces hydrogen, Z and SO4. Zinc valency 2, sulfate valency 2, equal valency, no exchange. Now another product is what? Water. Now what is the name of this compound? Zinc sulfate. Zinc sulfate. And another one, water. Now how to balance this equation? We'll start from this oxygen. Oxygen 1, we are not counting this because sulfate is present in both the sides. That's why we'll count sulfate. Oxygen 1, oxygen 2. That's why if we take here 2, oxygen is balanced. Oxygen, now hydrogen 2 2s are 4, 2 2 4. Okay. Sulfate 1 is balanced, and zinc 1 balanced. This way we can write balanced chemical equation, and this all these chemical reaction are acid base reaction.